All right. So, the question now. The last quiz I just gave you guys back from last time was the Facebook Friends, quiz. I originally was interested in the results of that because I thought it was interesting. You know, on average, your friends have more friends than you do. I sat down and tried to prove it mathematically. I can't. And in fact, not only did I not prove it mathematically, I found a counterexample to disprove it. So what I think has happened is some neat results occurred in a lot of cases, and people started realizing, oh, this is fairly interesting. You know, your friends have, my friends seem to have more friends than I do myself. And it was generalized, published. The mathematics has a lot of assumptions based into it, and like I said, I disproved it pretty quickly, so I kind of lost interest in that as far as the average number of friends. But I started thinking, we analyzed it two ways. We analyzed it first as the number of friends my friends had, and we graphed it in that histogram. Thank you, Pat, for pointing that out. I changed the quiz for the next crew because of that. Made the scale a little more logical. Appreciate that. But then we started counting the percentage of friends that had more friends than I did. Right? We started looking at that. What percent have more friends than I did? And I said, well, that's kind of a neat thing. We can actually, even when you have this crazy skewed distribution, you can still get something meaningful from it. Because we talked about averages. And what's the problem? Sorry. What's the problem? What's the problem? Speaking that register. Hello, I'm Sean. What's the problem with using averages and therefore standard deviations on fairly skewed data? What's the problem with that, potentially? Outliers. What about, I love this, I hear outliers, I heard a second for outliers somewhere. What's the problem with it, Nick?
If you try to find the average, it's going to focus on the outliers.
Boom! Your average, it's almost like the outliers have magnets that attract the average to them. So if you base your average calc, and the more extreme the outliers, the more skewed the average can go. So we lost that problem with the Facebook data as soon as we said, you know what, time out. It doesn't matter that one of Sean's friends has 2,300 friends or whatever it was. The average goes to that, but if we stop talking about the average and just look at the ones who have more than him, then I think I had 637. If somebody has 638, or if they have 2,638, or if they have 20,638, it doesn't matter how many more, just that they have more. So you do lose a little bit of detail, don't you? You lose a smidge of detail. You can't quantify how many more, but at least you can get to there's more, and you can express it as a percentage. So I started thinking to myself, how can we tie this into something else besides Facebook? Because Facebook is fun and cute and all, but how is it? So I started thinking, and I said, you know what? Perfect example, and it's probably occurred to some of you guys in your lives, and you might not have realized it yet. How many of you have been to a pediatrician appointment when they talked about your child or a friend's child's weights, heights, head girths, BMI calculations? I started thinking, I'm like, you know, this is the same math they use. So here's Max when he was 2. He's 6 now, but I've used this checkup, and you'll hear why momentarily. And you'll also find out why I'm not invited to go to any more checkups. This is what was told to me and my wife at Max's 2-year checkup. Max, 80th percentile for weight, 90th percentile for length, and my personal favorite, the 85th percentile for head girth. Tape around the head, even with the hair. That's at least 5 percentage points for the hair.
Obviously, they didn't know who they were dealing with.
Obviously, no. They support people. So the question is, answer Max's question. What does that? How many of you have heard these words before? A couple of you. How many of you nursing students are there? You deal with this, yes, I believe. Tease tests. You got to get in the, what, 95th percentile or something like that? Well, am I making stuff up now? It's something like that, yes? Yeah. Some percentile. Right, good, monster. So, explain to Max and me, his old man, while we're at it. What does it mean, 80th? So, if you can't explain the percentile literally, what does this mean about his weight? Is he a heavy kid or a light kid?
He's above average.
Above average. Okay, good. He's above average. I like that. What was the tip off there, Mom?
80%.
Oh, it's back there. Patty, sorry. What's the tip off?
The 80%.
So, what would average be?
50.
So, we have a vote for average would be 50%. I like that very much. Thank you. Let's hold that thought. I like that very much.
But
Patty,
you don't
go.
know what that number is. I mean, as a parent, you're like, well, for a 2-year-old, is it 40 pounds? Is it 60 pounds? What is the average?
See, Remember what we said just a bit before about Facebook, and we lose a little bit of detail. We know now that he's 80th percent, which apparently is above 50%, which is average, which is absolutely correct, actually. Well, ish. It's correct-ish. It's correct enough. We'll leave it at that. But what is it? Thank you. Thank you. We'll come back to that question, Pat, in spades. I got some data for us to play with. Max is in the data. I love that guy.
Isn't it, his weight is the same as other kids? This,
You got it. You've got it. You've got it. You've got it. It's right there.
other kids, 80.
No, you're saying it perfectly.
Okay.
You're comparing him to other white 2-year-old American males.
Right.
And you're looking at his weight, which, as Pat just pointed out, you don't see. You'll see it momentarily. I got a good data set to drop into.
Same as 80% of other
Good.
kids.
Hold that thought. This is perfect. You everybody hear what you just said? We're comparing Max, white American 2-year-old, to other white American 2-year-olds. How does his weight compare to them? Thank you. That's exactly what it is. We'll come back to that. Alan, go.
I was just gonna, now that I thought about my train of thought, I think it's incorrect, but I was gonna say that he weighs 80% more than the same age group.
Maybe that gives us a more of a look into what Pat is talking about as far as what the 80%, 80% more than the average, perhaps, of the same age group. I love this. I love every one of these analyses. And I'm going to start by saying this. There is no one uniform accepted definition of what an exact percentile is. I'm going to start with that right now. There is a general definition, however, and rather than just giving you the definition, which I think is lame, I want to show you some data. Here. There are 100, per your request, Doc, 100 weights of white American 2-year-old males. Go.
So what does the color of his skin have to do with his average weight?
You're comparing apples as much as you can, controlling for as many variables as possible, so the only variable is the weight. There might be, and I'm not saying there could possibly be genetic differences in weight, but the only way to rule them out is to not include any genetic differences, or not genetic, racial differences in weight, sorry, not genetic differences. So what I'm trying to do is isolate everything except the one variable, which is weight. If I include race, that's a second variable. Then we have an X and a Y. We got a scatter plot situation. And if I include males and females, then I got a 3-dimensional scatter plot, which looks red, but is a little bit more than what I want to do right now. See, does that make sense? That's a fantastic question. Everybody catch that question? I'm trying to control for as many variables as possible. I don't know if there is an effect with race on weight. But if I rule it out, then I know it can't be polluting my data if it exists. Fair-ish. I'm not trying to prove or disprove your statement. I'm just saying I don't want to think about that. Not that's it's a good idea.
Makes more
and it
sense.
might be. I mean, if in the news very often you hear things like, African American males have a more of an incidence of heart attacks than Caucasian males. I mean, there are times when you're interested in racial differences and results. I just don't want to compare that now, and you'll see why based on what one of the healthcare practitioners told me later.
Okay.
It's a great point, but I just don't want to get if it's okay. Go ahead, Carly.
If you took all of these data points and put them into a histogram with, then
Like
you
that.
have, right, so if you had
Thank you, segue.
the minimum outlier, would that be qualified as technically the 0th or the 1st percentile, and then the maximum would be the 100th percentile?
Can you hold that question for maybe 3 minutes? Because only because we haven't defined what a percentile is yet, so we can't talk about a 0th or a 1st until we kind of know what it is.
Well, okay.
And I'm not going to tell you what it is without looking at the data.
I was gonna keep talking.
So keep talking. Go.
Well, so then, if that was so if that was true, if that happened to
Sure.
be true, then I would see, for me, it would logically make sense to go one of two ways. Either one, take the minimum outlier as the 0th
Zero.
percentile,
Got it.
and the maximum as 100, and then divide the data into 100 even sections, and then you can find where your percentiles lie.
That's exactly what is done, believe it or not. That's exactly what is done. You divide up. You guys already know 1 percentile. You don't even realize it yet. And actually, Patty, you mentioned it. The 50th percentile is. Now, the trick is, without answering what it is, without telling you what it is, let's derive what it is from the data. But what you just described, Carly, is exactly the general idea of what percentiles are. Now, people get into fistfights about which formula we should use, and I don't want to worry about that. you've got the big idea. That's exactly what a percentile is. And we're going to restate that via this weight data. Fair? I thought I saw one more hand over here. Pat, was it you?
Yeah, but it doesn't mean anything.
Are you sure?
Well, I mean, you know, you talk about white American males. Well, you know, okay, compared to black. What about? I mean, are Italians heavier than genetically than?
Well,
than
hang on now,
Irish?
hang on. I'm only half Italian,
I know.
but he's only a quarter Italian. Yeah. So did my math right there, divided by 2. But the trick is, the reason I keep saying this, not to be racially motivated, but when you look at these, oops, oh crap, these, I mean, length for age, birth to 36-month boys, somewhere in here I pulled it up. It actually had white American male. It was actually classified by that. So I'm trying to use we'll come back to this too. What the hell we're looking at? We're looking at something interesting here, but I'm trying to stay with the tool that I'm able to use, which is minimizing that variation. I'm not saying they are or not. That's what I'm saying with Marty too. I'm not saying they are or not. I'm simply saying that. There we go. Good. So I'm just trying to say that I don't want to have another confounding variable that might or might not matter. I'm not saying it's not a good idea. It's a great idea in general. Just for my specific case here, it's not so much. Go ahead, Carly.
So, if that's how the percentiles are set up, then the average wouldn't necessarily be 50.
Thank you.
And
That
they
goes
don't-
back to what Patty said. Good.
And they don't tell you what the mean is, and they also don't tell you like what the standard deviations are. So they don't tell you that even if he's in the 80th percentile, that could be within the first standard deviation of the mean, and that's totally average. Or it could be, you know, within 3 standard deviations, and it's much farther from average. And you
camera's
don't
picking
know
up
unless
some.
you know the exact data points.
Perfect. Can you give me 5 minutes on that comment?
Okay.
On all those comments, because everything you just said, you sounded like me at the equipment 4 years ago. Believe it or not, I mean, you sounded exactly like I was when I was talking to them. You're exactly right. It raises more questions sometimes than it answers. 5 minutes on that, 3 minutes on your first, and I love the whole thing. So the first thing Carly questioned was a histogram. Now the first thing Carly and you all notice about this data is what?
Bell curve?
Ish. I would call it a little bit skewed, because you've got this guy over here. Now, we can get in fistfights all day long about whether it's bell curve or not. Arguably, it's bell-ish enough. You've definitely got this hump over here. And I like how Carly mentioned outliers down here. Maybe outliers, maybe just the smallest values. And that's something to get used to right now. We're going to keep talking about this over the next couple days. Just because a data set has small values doesn't mean that they're too small to be usual. Every data set has small values. But they might not be so small as to be ridiculously small or ridiculously big. It seems like we have smaller small values than larger. Large is a little dude out here, 33 pounds. But you see how close he is to the hump? That's not that far above, whereas these little dudes down here that are 20 are fairly far below the modal weights. The modal weights. Did you catch what Carly said too about how the 50th percentile might not necessarily be the average? Let's come back to that. It could be, and it doesn't have to be. So, Patty, what you said before, still perfect. There is a measure center. It has to be every time, though. More on that in a moment. More on that in a moment. Think about what that might be in the back of your mind. There is a measure of center that we learned about that the 50th percentile has to be. Come back to that in a moment. So we've already described this data pretty well, right? Where's Max? Max is in there. I stuck him in. I kind of lied to you. This raw data set is not really 100 randomly selected 2-year-old males. It's 99, and I shoved Max in it. So I knew his weight because they told me his weight, and then they took his weight and put it on the chart. But the thing is, if I wasn't there at the appointment, all I would have gotten was the chart with the percentile. So, where's Max? It's tough, isn't it?
Can you go back to the
Well, yeah, good. That's the whole point of the histogram, isn't it? Who asked me for that? Thank you, Jolene. Excellent. Guesses, go ahead, Jolene.
Well, I would just count how many kids are in each of the columns. And
Thank you.
80.
Beautiful. And there's a reason I used 100 of them. It makes the math easier. Check this out, friends. We just did that. Let's answer this question as Jolene is saying. How many of these 2-year-olds in this sample are less than 26 pounds? Strictly less than 26 pounds. Stand up if you have to. Take a look. Strictly less than 26 pounds. Strictly less, which means 25 or lighter.
20?
Got 20? Okay. So, in other words, 20% of the sample is lighter than 26 pounds. Fair enough? Now, how'd you guys do that? Pretty simple. We got 8 of them here. 4 of them here is 12. 14, 16, 17, 20. Boom. Fair enough? Got the counts there? Good, good. So do you think Max is 26 pounds?
No.
Doesn't seem like it, right? Based on these definitions you guys have been creating, doesn't seem like it. It seems like he should be above average. Where's average here? Where's average-ish? What's the average weight? Somewhere around here, 29, 30 maybe? Maybe a little bit south because of the tail, but somewhere over here, yeah? So I'm thinking that based on what Patty said about the 80 implying he's above average, which is a fair assessment, even though we're using the word average differently, he can't be 26 because that's too far below average. Carly, go.
Well, wouldn't that be 25 be the 20th percentile, not the 80th?
Using your definition, yes. That's what we're saying. Max is not there. Because that would be the 20th percentile based on the definition that we're discovering. Because a child, a white 2-year-old American boy who's 26 pounds is heavier than 20% of the sample. Now with a margin of error, we can apply it to the population as well. But yeah, that's right.
So would that kid be in the 80th percentile?
No, he'd be the 20th percentile.
Oh.
He's on the 20th percentile. So Max is on the 80th percentile. So try to envision where he is. Go ahead, Carly.
Oh, I think that.
Good, you got, hold that thought, that's brilliant. Veronica?
So wouldn't you just do the reverse and count back 20?
Exactly, so you can find Max that way. I have one inserted, because I was playing with the data, I'm like, this is kind of nice. Do one in between, do 29 pounds while you're at it. And you guys are correct, you've already figured out how to find Max, but this answers Patty's question from before. Strictly less than 29 pounds.
64? 64
I've got it.
percentile?
Hang on. I've got 15 and 16 is 31. Plus 11 is 42, 51. So 49? 49 less? 51 greater, 49 less? What I did was I added 29, 30, 31, 32, and 33, and then subtracted it from the 100. So there's 49 of them, yeah? So you got 49 below, 51 above. What does that sound like? Ish. It's not perfect, but what does it sound like?
Average?
It's the, which average? Guaranteed which average?
Of the 100 kids.
It's definitely the 50th percent, the 49th percentile. But what did we just do if we found a data point where half of the data is below it and half is above or at it?
The median?
We just found the median, didn't we? Yes. Yeah. The median is always the 50th percentile. Always. Always. It has to be. Based on this definition, we've established a percentile. Based on this definition of percentile, it has to be the 50th percentile at the median because the median separates the bottom half from the top half. So Patty, when you say average, I agree with you. It's always the median. Could it also be the actual average too? Could it be the average and the median are the same thing?
Yes.
What does the data usually look like when that happens?
Bell curve.
That's where the bell kicks in. When you've got a bell curve, the median and the average and the mode are all basically the same number. That's why this one is getting a little bit leany as far as that goes. The average is going to be a little bit below median, but it might not be arguably significantly different. Is that fair? Veronica, did you find Max yet? Did you find Max yet?
No.
Find Max! Based on the fact of what we just did with 26 and 29 pounds, we just discovered that the 26 pounds is the 20th percentile because 26 pounds exceeds 20 of 100. That's 20%. 29 pounds is essentially the median because 29 pounds exceeds half the data. Find Max. Find my boy. Find my boy. Everybody do it right now. Find my man.
31?
31? 31? Yeah, 31. We got some 31s. So if you look at 31, actually, probably the easiest way to do is go above at this point, right? So this kid here is the 99th percentile, isn't he? Because he's bigger than everybody except himself. So he's bigger than 99% of the sample. He's the 99th percentile. How about these kids right here? Well, there's 8 in there, and there's 1. That's 9 altogether. These kids are the 91st percentile, aren't they? Because they exceed 91% of the values. I'm treating the sample as the population with your permission. I built the sample off the population, randomly sampling from the population. We're ignoring a margin of error if it's okay with you guys. We'll see why momentarily. 31, so that's 9 plus 11, that's 20. Which means these kids are heavier than 80%, which makes Max the 80th percentile. He was 31 pounds at this checkup. There's your weight, Pat. And that's awesome. It's like, wait a minute, but how did you reverse engineer that? More on that to come. We'll get to that in a second. But But the idea is you just answered the question. The percentile definition that Carly outlined for us before is exactly the general one I want you to remember. All percentile ranks are. Now you can micromanage them. You can micromanage them much in the same way as you can micromanage, say, a filing system in your desk. But the big idea is you put folders in your desk. That's the big idea. You have folders in your desk, you put stuff in the folders. How you choose to do that is kind of up to you, but the big idea is a percentile rank simply reflects the proportion of data a given point exceeds. That's it. That's it. Count them up, divide by the total, yep, done. You guys might remember the first quiz or two I gave you in this class, the primer quiz where you went into Excel and selected a whole bunch of data and counted how many were less than this. I was getting you ready for this. The whole point was getting you ready to look at a data set like Max and be like, put it in a histogram first of all. Thank you, Carly, for that request. I'm sure a bunch of you were thinking that. Like, this is annoying to look at. Let's look at something more logical. Yes, very good. But then being able to simply count and divide and get a percentage. It's amazing how little you do that in like Math 111. In Math 111, you're always solving quadratics and exponentials, and you forget how to like divide. It's amazing. I put this, however, here because people do get into arguments about what formula to use. So, Carly, back to your definition, or your question about the smallest kid on the block. The smallest kid in the sample was, can I back up a slide, friends? He was 20 pounds. Actually, there were 3 of them, weren't there? What are they? What do we call them? Just so you know, there's more than one correct answer for this. What do you call them?
Below average.
The lowest. As a percentile. Below average for sure. I like that. The lowest, below average, good. What do you call them as a percentile? First percentile? I heard 0th percentile back there, I believe. I heard 0th, maybe. So, if we use the literal definition of the proportion of the data that these kids exceed, what percentile would they be?
3%.
They'd be the 0th percentile. They don't exceed anybody. They're the lowest. So if we go literally with that definition, they'd be the 0th percentile, couldn't they? I mean, they have to be, yeah? Now, here's the thing. Sometimes people call that the 0th percentile. But I have yet to see the 0th percentile actually occur out in the world. It's always the 1st or 2nd or 3rd percentile. And I think the reason is there's probably always going to be someone a little bit smaller. Like finding that smallest 2-year-old kid, I mean, you know, I don't know what he looks like, but there's always going to be a smallest, and the chance of us catching him in a sample is basically nil. So depending on the formula you use, and Laura only knows how many are out there, dozens, I'm guessing. So you can go ahead and call him the 0th percentile, call him the first, call him whatever you want. The idea is making sure you're close to 0, whatever you call it, and make sure you back it up. Go ahead, Joe.
So if it were possible to have a 0-pound 2-year-old, your data would start at 0.
Essentially it would, wouldn't it? And even he would have to be, this poor little dude, would have to be, even his hair doesn't weigh anything. Even he is the 0th percentile by my definition. Even if the data starts, it really doesn't matter. This is just relative to the context of what we're talking about, which in this case is baby weights. Fair?
Fair.
Go ahead, Linda. Yes, 100% correct. Did you want to go further with that, Joe?
No.
That was just a question. Yeah, it's almost irrelevant what's on the horizontal axis. Sometimes it starts at 0. The data we're going to play with later today does start at 0. Both sets we're going to play with today start at 0. So it all depends on the context. They could literally be negative numbers too, theoretically. If you're talking about, say, weight changes in a diet, or weight changes through the day, what's the biggest temperature drop Ben has ever experienced? Well, maybe it's negative 32 degrees. It went from 32 to 0. That would be south of 0. But there'd still be a number of days where that happened. So you'd be counting positive frequencies on a negative number. So don't get too hung up on the axis. Just realize there is a low value of any data set because they're finite. Go ahead, Linda.
Did you argue that are these children that are underweight, are they
Random sample.
Are they sick? Are you know?
Random sample.
Yeah.
I mean, define sick. That's the thing too. Like, am I injured really? I don't know. Maybe.
Right.
Please, these are just a random sample of 2-year-old white American males.
So to find any percentile on there, like 25, you just count what's below it.
Exactly. That's all you got to do. It's like I'm going to have you guys each calculate your own percentile in a moment after our break, so you get this kind of driven home, so you understand the math behind it. And there are different calculations. Remember how we talked about this kid right here being the 99th percentile because he exceeds 99%? I don't want to confuse you, but one formula that is sometimes used is don't just count the ones that are below, but count half of those that are with you. So, to use a better example, let's use 32 pounds. We call these guys the 91st percentile, yeah? Some formulas, where one in particular says, yeah, count the 91 that are below, but also take the 8, cut that in half, 4, add that into the 91 and call these kids the 95th percentile. The argument being that they're not bigger or smaller than each other. We kind of have to shoot to the middle of each of their bars. That's a valid argument. I got no problem with that. And I'm saying, I don't exactly know, when you guys use technology to calculate this, I'm not even sure which one it's using. So what do I want you to take away? What's the big idea I want you to take away about percentile? Put it in that box. That's the big idea. We can get in fist fights all day long about which formula to use, but the reality is it doesn't matter. It doesn't matter. What matters is when a kid's in the 80th percentile, they're bigger than 80% of the kids. Pat?
You're always counting back on that histogram though, right? So
that's the definition of percentile, yes.
So there's no, that's why that, because I'm thinking, okay, well if there's 3 in there, because we're counting, then it's 3%, he's in the 3rd percentile, but actually it's not because there's nobody below that.
By this definition, yes. Okay. By this definition, yes. And by that second definition I just mentioned, they'd be the 1.5 percentile. 3, cut it in half, 1.5, 1.5, that's hard to say. 1.5, that's even harder to say, percentile. So yeah, you're always counting backwards though. You're always counting backwards. That's just by definition of percentile. So on your Facebook quiz I just made you guys do last class, I had you count the ones who had more friends than me, and I think it was 22%. That means that I am in the 78% as far as friend ranking. Does that make sense? Because I had more friends than 78%. 22% of my friends had more, but I had more than 78%. Does that make sense? Mm-hmm. So that's how the percentile. Sometimes you'll see percentiles indicated in the reverse direction, but they won't call them percentiles. They'll say something like, yes, but only 20% of the boys are heavier than Max. It's not a percentile. Percentiles go down. Just by definition. I'm not saying that's a good reason. It's just that's the definition we're stuck with. Is that fair? Ask me more questions right now that you have them. And I'll share the story when we get back from break about why I'm telling you all this. Well, besides the fact that it's an interesting thing about percentiles. Marty, go. Please. No. Still formulate the question? Maybe.
Yeah, no.
Maybe? Think about it. Let's take our 5, yes? Let's take our 5. If we got questions about assessments, let's ask them. I'll come back and I'll tell you why I like this particular example as far as learning about percentiles. So, oh, thank you. Did you hit the camera?
Yeah.
You're the man. Thank you.